Calculating the specific heat capacity of a substance by KayScience.com. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. So you can write the specific heat capacity equation like this. Energy transferred equals mass times specific heat capacity times change in temperature. To rearrange it, I like writing it like this. The energy transferred over mass times specific heat capacity times the change in temperature. Because then all you've got to do is cover the subject that you want to work out and then rearrange it like that. So we cover C, the specific heat capacity, which gives you C equals energy transferred divided by mass times change in temperature. So we've got a 3 kilogram block of copper, which is at 8 degrees Celsius. 26,565 joules of energy have been transferred into a thermal energy store of this copper. And this 3 kilogram block of copper increased its temperature from 8 degrees Celsius to 31 degrees Celsius. Because 26,565 joules of energy were transferred into the thermal energy store of the 3 kilograms of copper. So we can use this information to calculate the specific heat capacity of copper, whereby we can work out the number of joules required to heat 1 kilogram of copper by 1 degree Celsius. So the information that we have is the energy transferred into the copper, which is 26,565 joules of energy. We've also got the mass, which is 3 kilograms. But we don't have the change in temperature. We must work that out. So it's 31 degrees Celsius minus 8 degrees Celsius, which equals 23 degrees Celsius. So we've rearranged the equation for specific heat capacity C. So C equals the energy transferred into the copper divided by the mass times change in temperature. So C equals 26,565 joules divided by 3 kilograms times 23 degrees Celsius, which gives you a specific heat capacity of the copper of 385 joules per kilogram per degree Celsius. So to increase the temperature of 1 kilogram of copper by 1 degree Celsius, 385 joules of energy must be transferred into a thermal energy store of the copper. It's question time. Attempt these questions to check your understanding. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. So you recall the equation, energy transferred equals mass times specific heat capacity times by the change in temperature. But we're trying to work out the specific heat capacity, so we rearrange for C. C equals energy transferred over mass times change in temperature. So we're trying to work out C, the specific heat capacity. So it's C equals the energy transferred into the lead, which is 19,500 joules, divided by the mass, which is 2.5 kilograms, times by the change in temperature. So the change in temperature is 80 degrees Celsius minus 20 degrees Celsius, which gives you a change in temperature of 60 degrees Celsius. So it's the specific heat capacity equals 19,500 joules divided by 2.5 times 60, which gives you a specific heat capacity for lead of 130 joules per kilogram per degree Celsius. So to increase 1 kilogram of lead by 1 degree Celsius, 130 joules of energy needs to be transferred into a thermal energy store of the lead. We've already rearranged the equation, so C equals the energy transferred into the thermal energy store of the water, which is 40,320 joules of energy, divided by the mass of the water. And the mass of the water in this example is in grams. you must convert the grams into kilograms. So it's not 200 grams we're going to use in the equation, it's 0.2 kilograms. And you multiply the 0.2 kilograms by the change in temperature. So it's 52 degrees Celsius minus 4 degrees Celsius, which equals 48 degrees Celsius. So that gives you a specific heat capacity of water of 4,200 joules per kilogram per degree Celsius. So to work out the specific heat capacity of oil, you do 140,800 joules divided by the mass. So it's not 80 grams, it is 0.8 kilograms times by the change in temperature, which is 100 degrees Celsius minus 12 degrees Celsius, which equals 88 degrees Celsius. So you multiply 0.8 kilograms by 88 degrees Celsius. So the specific heat capacity for this cooking oil is 2,000 joules per kilogram per degree Celsius.
It's question time. Attempt these questions to check your understanding. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. Visit KayScience.com for more free videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.